So my name's Robert Day. I have a day job, which is I run the automotive go-to-market for ARM. And I have a night job, which is I am one of ARM's representatives on the SOAFEE governing body, and I also currently chair the MSC. So all I can say about that, and I'll tell you more about sort of how SOAFEE's doing, is that night job has become a late night job. So there's a lot of stuff going on with SOAFEE, and I'm going to try in the next 40 minutes or so to take you through it. Okay. So we're going to talk about SDV. So what I'm going to do first is give you some of the trends that we're seeing and we were seeing, which basically is why SOAFEE was formed and what we're trying to do with SOAFEE. So the thing about SDV is it's already underway. So this Gartner survey, you can just see source Gartner, basically saying 50% of the top 10 automakers will offer new features through software updates. That's software defined. That's a lot of the crux of this. So it's happening. Why is it important? So firstly, this software defined functions and the updates and the upgrades and everything else, they're going to enable new business models for the automakers. They're actually going to also offer a closer relationship between the OEMs and the customers, the consumers of their vehicles. However, in order to get it to work, you need to do early software development, and that's kind of what we're going to talk about today with SOAFEE. And we really believe that the software-defined vehicle is really survival for the automotive world. So let's have a look at, what do people think about new business models? So this is a study that was done with Aurora Labs and Strategy Analytics, basically going out to consumers of vehicles. And as you can see here, a large percentage would pay up to $20 a month. That's a revenue, it's a business model, it's a subscription model, okay, for additional services after buying the car. And 14% would even pay up to $50. So obviously the 14% is the ones we want to find. Okay, so what does it mean as far as the requirements? What's going to make this different, and why do we have to do things like SOAFEE? So a lot of this is going to be the delivery of these new features, advanced features. The car is going to be defined by software. It's going to require new innovation. It's going to require agile development. Okay? So updatability, security, and scalability. These are all keys behind the software-defined vehicle. What does this mean for compute? So in my day job as ARM, we worry about what do we have to do to support the software-defined vehicle. My night job is when we talk about how we make that software run on the lovely ARM processors that we provide. So as we get more software in a car, okay, you're going to need higher performance processors. They still need to be efficient. So we still need to worry about the power consumption of those compute systems. We can't just put a rack of servers in the back of the car and expect it to work efficiently. And also it's got to be cost effective. So although the consumers said they'll pay extra per month for some of these features, they're not going to pay a lot up front just because you happen to put a ton of compute in the car. So it has to be cost effective too. So one of the things we've been paying attention to, and I hope this sort of resonates with what you see, is the change in the computing architecture. And this is all very relevant to software-defined vehicle, SOAFEE and everything else. We see the traditional architecture with a bunch of ECUs connected on CAN buses on the left here. We're now starting to see consolidation into domains with domain controllers for different functions. But what we're also hearing about is this sort of like future generation of a zonal architecture with a centralized compute. And that's a lot of what that change is going to require, a change in the way we develop and deploy our software. So one of the nice things is that lots of software is already being developed and deployed in different places. So cloud, smartphones, we're getting these continuous updates, deployments. It's already done there. Now, a car isn't the cloud and it's not a cell phone, but we can take some of those different development processes and bring them into the automotive world. And I'm kind of leading up to what SOAFEE is all about, really trying to show what the reasoning behind forming SOAFEE and the architecture of SOAFEE. So one of the things we've been looking at is, as I said early on, is starting development early. So there's something called shift left. And you can see the top there is the sort of normal way we develop our different functions in a vehicle. So, we'll do this, we'll have the SOCs being done, we'll then do the ECU, we'll bring the software in, we'll sell the car, and then off it goes. The software-defined vehicle needs a different approach. And that's where we're advocating looking at, taking these methodologies that come from the cloud, or cloud native as it's known. And what that allows us to do is to start software early. That's the, let's see if I can use the laser. That's this blue box here. So you're basically developing your software in the cloud in parallel with all the other stuff that's going on, the SoC design and everything else. Starting that software early is vital because there's going to be a lot more software, but it also allows us to then start bringing that onto the hardware and actually bringing the software development cycle a lot shorter. So that's the shift left part. The other important bit is over here, is once the car has driven off the forecart and you've got it on your driveway, it doesn't stay like that. If you think about how you work your cell phone world, with the updates and new applications you've got, your cell phone generally gets better over time to a point where you have to buy a new one because the hardware won't run the software right. But generally your cell phone gets better. Your car's going to be the same. Your car is going to get better over time. And that's going to be a really interesting dynamic between the people building the cars and the consumers of those cars and the expectation of those consumers. So this is the final slide before I start telling you about what SOAFEE is. So what we've seen is that if you start getting into cloud native development methodologies, then there are things that you do in the cloud that we can take advantage of in the vehicle. So the first is this thing called CI/CD, continuous integration, continuous delivery. So what's happening is you're continually developing your software and then you're putting it out there to your cell phone or your cloud instance or whatever. And so having that available for vehicles would be a great thing. You can start pushing out these updates, these software updates. There's another part to this. In order to do that, we actually have something called orchestration. I'm going to talk a little bit more about orchestration and what that means in a bit. But that actually allows us then to bring that software down to the vehicle, which is here. The other change that we're seeing, and this is something that's, again, from the cloud world, is this moving into something called microservices. So these are smaller pieces of software that can be more easily and agilely updated. There is a lot of discussion going on right now whether that's a good thing or a bad thing, but it certainly can work well for certain applications within the vehicle. And so, because the vehicle isn't the cloud, we need to worry about things like mixed criticality. We need to worry about functional safety. We need to worry about real time. We need to worry about having different types of compute systems within the vehicle. You don't need to worry about that in the cloud. So that's why we formed SOAFEE. So SOAFEE stands for Scalable Open Architecture for the Embedded Edge. So it's not actually specific to automotive. It's just the software-defined vehicle is the kind of like the killer use case right now for having this cloud-native environment for, basically mixed criticality systems. So SOAFEE got kicked off a couple of years ago. It's an industry initiative. You'll see the members in a minute. And it's really to bring this cloud native over to automotive or the embedded edge. Okay? SOAFEE is primarily an architecture. Okay? We're defining an architecture that will allow you to do this cloud native development, allow you to use cloud native technologies and methodologies, but at the same time, understanding that the car has these different characteristics to the cloud. So that's what we're really doing, is the SOAFEE Special Interest Group is really defining this architecture, and we're using existing standards in order to do that. And then we will look at how those standards need to be extended to basically, meet the requirements of vehicle development. The funny thing about these, industry working groups and special interest groups and whatever, is if you don't have something that people can play with, if it's just slideware, it isn't real. And so what we did from day one is we actually came out with an open source reference implementation. It's not designed to be deployable. It's designed so that you can get started developing, you can get started using these different types of cloud methodologies in order to do your prototyping and early development. You remember we were, the shift left side of things? That's what this helps. So the objectives of the SOAFEE SIG, I've covered most of them already. It's basically bring together both automotive companies and the software cloud ecosystem. Okay, it's going to take everyone to come together to actually make this work. And then look at these different cloud native standards and how we can use them, what we need to do with them in order to make them relevant for the vehicle. We're going to deliver this reference architecture. As I say, it's the number one priority of SOAFEE is to build this, give this architecture with guidelines and also a roadmap to how we get to what I'm going to tell you about in a minute, and then have this reference, open source reference implementation. Now, any of you that were here in the other session, we knew these objectives haven't changed since we formed SOAFEE. So these were our objectives 2 years ago. They're still the same right now. And it's really looking at how we as an organization, as a special interest group, can work with other organizations that are looking at software and software for vehicles. Okay, we're not trying to do it all as SOAFEE. We recognize that there is a real opportunity for synergy and collaboration. Okay. So this was the founding governing body of SOAFEE. Formed in 2021, so I say it's almost 2 years old. And what we wanted to do when we formed SOAFEE was to have governing body members that have a different view of what's needed and have different expertise. So we have a couple of OEMs. We have Cariad here. We have Woven Planet and Toyota. We wanted to get the consumers of SOAFEE along with our tier ones, Bosch and Continental, because ultimately they're going to define what this needs to look like and whether it's going to be usable for automotive development. Okay. We also wanted to have some software companies, so we have Red Hat and we have SUSE because of their orchestration expertise, and we wanted a CSP, so we have AWS. So in this kind of 8-company governing body, we've gone kind of across a lot of the types of organizations we wanted to have. So since we formed it in 2021, the next thing we wanted to do was to put together, what the SOAFEE Special Interest Group looks like, what it is we're going to do, define what work we need to do, define what the working groups are like, and then basically bring new members on board that have expertise or technologies in those different areas. And I'll kind of go through some of, what we were really looking for. So, as I said, we've got this open source reference implementation. Yeah, it's great. It's great to see how SOAFEE works. It's great to use the tooling around it, but it's not designed to be deployed. So we needed to have companies coming in that have deployable technologies for automotive and will fit into that SOAFEE architecture. Remember, SOAFEE is an architecture. The technologies that go into it can be open source, they can be commercial. And in order to get to deployment, which is what's the requirement for OEMs and tier ones, you need to have commercial technologies. So unfortunately, this has become a little bit of an eye chart now, but we're now at, as of May, we're now at 88 members of SOAFEE. So within 2 years, we've basically gone across pretty much the whole software, system integrators, CSP, hardware companies, anybody that's involved in providing technologies or expertise for this software-defined vehicle are here. And if you go to the SOAFEE.io website, you'll see this list. You'll also see what each of them brings to SOAFEE. So the SOAFEE work group, this is what we defined as the governing body. It's changed a little bit over the last couple of years, but not dramatically. So you can see we've got the governing body. The chair of the governing body is Bill Foy from AWS. We have a tech steering committee and a marketing steering committee. As I say, I chair the marketing steering committee for now, and my colleague Matt from ARM chairs the technical steering committee. And then we have two sets of working groups. We have the architecture working groups, which is the blue box on the left there. That's helping define what this architecture looks like. What the architecture looks like, what the requirements are for the tooling that will go with that, what the requirements are for the standards. That's what these three working groups are really looking at right now. Then we also have the reference implementation working group, and that's basically building our open source reference implementation, but it's also working with the commercial companies so they understand what being, SOAFEE compliant really looks like. So this is the working group structure. It's active, as you saw, the members, involved with these different areas, depending on what their expertise is. And this is a kind of high-level view of what the architecture looks like. We essentially have the top bit, which is this is the cloud part. And you can see we have things like virtual compute environments running in the cloud, digital twins. That's all kind of part of what SOAFEE is going to enable to start that cloud development early. Then you can see we have the containers, and the containers is a kind of key part of how you deploy these microservices into both the vehicle, but how you develop them in the cloud. And you can see then we have these different applications or services which are housed in these container runtimes. So then we come down to the cloud, and this is where we bring the orchestration in, and the orchestration is going to allow you to bring these from the development in the cloud down onto the vehicle. So this is the vehicle. You can see we've got a very similar architecture. We have the OS and a hypervisor. We have a orchestration runtime. We have the container runtime. So that's what's going into the vehicle. And this is basically the high-level SOAFEE architecture that will allow you to basically get from developing in the cloud, deploying in the vehicle. Back to my shift left diagram. Okay? What's interesting is we're now starting to also see there's the opportunity for something called environmental parity. So because a number of the cloud service providers are now running on different architectures, including ARM architecture, we can actually have the same ARM architecture in the vehicle as in the cloud. That helps with this initial development, because if you're developing in the cloud on the same architecture, it makes it a lot easier to bring that down. We have demonstrations on the SOAFEE website that actually show how you can take an application, containerized application, run it in the cloud, and then basically bring that exact same container and runtime image to the edge, and it just runs the same, and the results are the same. So that's sort of the nirvana state, but we're not far away from it. And as I say, there are good demonstrations and good examples of this going on right now. So what we're focusing on in SOAFEE is really looking at how we can understand what the vehicle looks like. So that means that we have to look at an orchestrator, and the orchestrator has to know where the software is going to land. Okay, so it has to know about the properties. What sort of processing is it doing? What's its real-time requirements? What's its safety requirements? And that's not something that's in normal orchestrators or normal orchestration standards. That's why it was important for us to have folks like Suze, because they can kind of help. They know how orchestration works. They can help with that. And one of the first sort of sub-working groups that we came up with in SOAFEE was the mixed critical orchestration working group, looking at what we need to do for those standards to make them work for a vehicle. Oops, wrong button. So this is a sort of slightly more detailed view of what a SOAFEE architecture could look like with the mixed critical workload orchestration. Whew, that's a mouthful. So this is really showing we've got these different microservices. They're going to be running on different types of operating system at different levels of safety. So again, this is an example of how you could have, you know, different safety levels even running on the same hardware, and different operating systems. Oops, let's just get this running along the pipe. The other kind of interesting part that we're really trying to define as part of this is having, you know, the main processing, but also then having basically safety, things like safety islands running your software. So we understand these are really going to be heterogeneous architectures that the vehicle, and we need to support that. And the orchestration needs to understand how that works. So now I'm going to try and put this diagram into something you all should understand, which is AutoSAR. So I'm going to start replacing this with AutoSAR parts. So you can see on this right-hand side, this is where we could have AutoSAR Classic over here, okay? Then we can also, even on this side, have another AutoSAR Classic. And then over here, we could have AutoSAR Adaptive, potentially with a container runtime, then running these containerized workloads. That's our vision for how AutoSAR, you can take and develop AutoSAR applications and workloads and basically bring them into this SOAFEE architecture. And that's a lot of what we're discussing right now is how do we make this work? What does it look like? You know, the majority of the AutoSAR providers are actually members of SOAFEE now. So we have people that, you know, live and breathe this, actually kind of working in the SOAFEE world. So this is the reference stack. You'll see in a minute I've got a really quite complicated roadmap. This is just the roadmap for the reference stack. So we really had to come out with something early on that will allow people to start working. We actually even had an application. We had the AutoWare autonomous stack as an application, and I'll talk more about that in a minute. At the end of last year, we released the second version, and then we're now planning the third version, probably towards the end of this year. And what we're doing with each of these is bringing more functionality that will get us closer to the overall SOAFEE vision. We also need some platforms. So from day one, we decided we're going to have some reference implementations. So we actually developed one here along with AD-Link and Ampere, which is like, it's a 32-core server chip. So it was basically over-provisioned because we didn't know what software workloads you're going to want to run on it. So this thing's a good development platform that will run the reference stack that will allow you to get going. But then we really need to have our partners, and we've got more of these coming. I just haven't updated this slide, where we're going to have more automotive-grade systems, SOCs or whatever, that will basically run this same SOAFEE environment. And over here, we've got the AWS SOAFEE AMI, Amazon Machine, can't remember what it's called now. But basically, this is running SOAFEE natively in the cloud, okay? And then over here, we've got development systems that we're looking at just to kind of get people going, you know, with these off-the-shelf maker systems. So we've got the Turing Pi and the Raspberry Pi as good examples. The nice thing about SOAFEE, and one of the key parts of it, is this portability. The portability of software, regardless of which platform you happen to be running on. What you develop on, what you deploy on, are probably going to be not the same. If you remember that shift left, we were developing software at the same time as the SoC was being put together. As long as you know what the architecture is going to look like, it means that you should be able to basically, you know, deploy these software workloads easily across different hardware platforms. So this was the vision of SOAFEE. It now has a name. So it was first called Moonshot, and then somebody pointed out that most moonshots aren't actually all very successful. So we renamed it Project Eagle because that was the first moon lander. So there you go. That's a little bit of SOAFEE history for you. What we're trying to do here is get it to the point where people can really start using this SOAFEE environment. And we're pretty much there right now. So we have this concept of blueprints, and these blueprints are generally application-specific workloads that are put together by SOAFEE members to run in a SOAFEE environment. And I'll share with you some of the ones that we've got going right now. Okay? Then what we want to do is to have these things called integration labs where we have different hardware platforms that these blueprints run on. So it's giving a potential consumer of SOAFEE the opportunity to use a workload that's going to be familiar to them and then run it on hardware platforms that could also be familiar to them. So it's really designed so these, I told you all about the portability. Well, that's what these blueprints are supposed to show. It can be portable over different hardware. It could also be portable over different operating systems, for example. So it might be you start with the open source reference implementation based around Linux, and it might be you then move to QNX or Greenhills or whatever. And that's the whole point of having our commercial partners involved there. Your workload shouldn't change. So here's a few of I think these are all on the SOAFEE website. So the first blueprint was something called the OpenAD kit, which is AutoWare's autonomous stack. And I'll go through that in a bit more detail because it was a really interesting process going through this. We then have now another blueprint that's come from Red Hat, which is really looking at this orchestration side of things. So it's not really an application per se, it's more a particular function that we need to show off within the SOAFEE world. We have Iceberg, which is a code name from AWS, which is actually a connected vehicle example. And this one's been submitted. I think this will be going through quite soon. So the first two are already out there. You can actually go find them, play with them, do whatever you want. Then we have some other ones coming. We have a digital cockpit. We have something which is actually kind of key to the Eclipse SDV side of things. It's bringing some of these other workloads in as part of the SOAFEE implementation. So what we're trying to do working with these other organizations is to actually make it real. And these blueprints can make it real. And then we're looking also at these virtual platforms. It's really important if we're going to start our automotive development early in the cloud that we have good representations of what the final system's going to look like. And that's where these virtual platforms, virtual prototyping environments, digital twins, they'll be able to take more of your software and actually run it in more of a representative environment, even in the cloud. So I'm going to take you through blueprints. These, I think, are going to be a really important step in the SOAFEE journey for people to be able to take and use something that's tangible. We came out with the open source reference implementation early on because we wanted it to be real and let people play with it. What we've realized is you need something that's more representative as a workload for people to really get involved with it. And that's what these blueprints are. So you essentially have, the different SOAFEE elements here. We have the software stack, the compute platform, and then application-specific workloads. Those workloads run in containers. They run right now on the reference implementation, and then they run on the relevant hardware platform. So the first one was this thing called OpenAD kit. So we took the AutoWare stack, working with the AutoWare Foundation and Tier 4, and basically split it up. So it's a big monolithic stack. What we want to do is to show both the containerization of the functions, but also the communication between those containers and make sure that works. So we cheated a little bit because what we did is we actually ran full-blown AutoWare, 4 of them in 4 different containers, and we just picked the right service. Rather than actually chopping the code down, we kind of cheated, just to prove that we can run in containers and the containers can talk to each other and all that sort of stuff. And it works. And it works well. And that was the OpenAD kit, the initial version of that. We're not stopping there. So what we now are doing is basically cutting down those into their, what we're calling microservices. They're kind of not really, because they're still quite big, but basically pulling them down into their thing. And again, showing how these containers can actually be, basically up and downloaded or downloaded independent of each other. So you don't have to do the whole stack. You can actually just bring in different components. And so again, this is the next version of the OpenAD kit. So it's a really good journey for us to go on as SOAFEE, and also for our members to see how this works, because that's what's going to happen in the real world. This is where it gets really fun. Well, I think it's fun. Okay. So at Embedded World, one of the SOAFEE members, a company called Kern Concept, decided to take this OpenAD kit blueprint, okay, and actually take one of those containers out and move it away from running on the normal hardware it was running on. I'm going to move it onto a safety island. So they actually moved it over here. So this is the majority of the services, and then basically over here, they basically took the vehicle interface, the bit that needs to run in a safety environment, and they basically ran it on a different architecture. It's Cortex R52, ran on their hypervisor, and then basically run those in VMs. And these are all running the normal. So this is a really good example of how people can use these blueprints. They're real, people can take them, they can bring their own technologies and their own services in to show how these applications and these basically become a more deployable representation of the blueprint. This was live, it was running at Embedded World, it was really cool. Okay, so here's another eye chart for you. This is SOAFEE roadmap. The problem with SOAFEE is that it's an architecture, so the architecture has to have its own roadmap swim lane. That's up at the top here. Okay, and we have a bunch of use cases that are used to help define what the architecture looks like. We then have the different releases of the open source reference implementation. We have different working groups that are doing different parts, so they have to have their own thing. So then we have the different blueprints. We've already seen those. And then down here, this is going to be a kind of key part. We're going to have partner reference implementations. So we got the open source one. I've already said no, it's not designed to be deployable. So we're going to have partners doing it. And Red Hat did the first one with their Automotive Stream distribution. Here's the cool thing they did, is they ran the OpenAD kit blueprint on it. So not only are they doing their own SOAFEE compliant commercial offering, which you can then take and buy whatever from them, but they're actually running the blueprint to show how it works and show how that blueprint is portable. So we are really kind of, as SOAFEE members, we're really dogfooding here. We're really using this thing, and we really believe that the architecture concepts are strong. We still have a long way to go, especially around mixed criticality, but we're starting to really use this in anger, and the blueprints help that. So I don't know if any of you have seen this diagram before. This is how we all work together. So we came up, I'm going to give credit to Daniel Krippner from Bosch. I wanted to have a way of showing how the different organizations simply can kind of work together and who's out there. And so we can see over here we have AutoSAR. So each of these is a planet. There's no sun. They're all planet. And then we actually have moons for some of the different projects within them. And we're trying to show how these different organizations can work together, are working together, or planning to work together. And even in a relatively simple diagram, you can see there's quite a lot of these organizations that we believe have to work together. And so, interestingly enough, I've seen this diagram used by other organizations now, which is good, because I think it really tries to show at a very high level, what we're trying to achieve here. Okay, so hopefully, those of you who didn't know what SOAFEE was now know. Hopefully, you're all excited to get involved with SOAFEE. Especially in the SDV world. And so the SOAFEE.io website has quite a lot of stuff on there now. There's even, we did a symposium last year, there's video recordings of that. You can hear from SOAFEE members, you can hear from the SOAFEE governing body, that's all out there. There's a SOAFEE Slack channel you can join if you want to kind of see what's going on. You can get either the reference into implementation or blueprints and start playing with them. And you can consider joining SOAFEE SIG. If you're interested in joining, there's me. Just ping me. I will tell you everything you need to know about joining SOAFEE and more. With that, I'm about on time-ish.
Yeah. Time for maybe one or two questions. Thank you, Robert.